Hello, this is Teacher Dong, and today we're going to talk about roots of quadratic equations. In this specific lesson, we're going to get the nature of roots, sum, and the product of quadratic equations. So for your reference, you can read on your books from page 24 to 33. Now, let's have our initial activity so that you can recall if what is the difference between real and non-real numbers. For the instruction, we have to write if R if the number is real and NR if the number is non-real. For number 1, we have the square root of negative 15. If you are going to use your calculators and compute for the square root of negative 15, the answer that you will get is math error. It means that there is an answer but it is undefined. It is undefined. So undefined numbers and imaginary numbers fall under non-real numbers. So when we are talking about real and non-real numbers, these are part of the real number system. So under real numbers, these are numbers that can be represented in their exact values. Example, we have integers, fractions, decimals. Then for undefined and imaginary numbers, these numbers are non-real. Let's have number 2, square root of 25. So if you will simplify square root of 25, it is positive negative 5, and positive negative 5 is a real number. Number 3, 24.5, and 24.5 is decimal, and decimal numbers are real numbers as well. That's why this is also real. Then number 4, square root of 15 over 9. If you will be simplifying this one, okay, you will be getting a decimal, or if this is already simplified, but it is written in fractional form. So this is also a real number. Then last one, number 5, square root of negative 21 over 9. This is non-real number because if you will simplify square root of negative 21, you will get math error on your calculators, or the answer is undefined. That's why this is real. So those are the things that we need to recall so that we can actually go ahead with our lesson about nature of roots of quadratic equations. I hope that you are able to recall the real number system with this activity. Next, let's have nature of roots. If A, B, and C are real numbers, and D means the discriminant, D is equal to B squared minus 4AC, then the roots of the quadratic equation AX squared plus BX plus C equals 0, which is the standard form, are first condition real and unequal. So this is if D, or the discriminant, or the value of the discriminant, is greater than 0. It means the solutions or the roots of the quadratic equation are real and unequal. So this is applicable if the discriminant is positive. Then next condition, real and equal. This is if D is equal to 0. So if D is equal to 0, or the discriminant is 0, the roots or solutions of any quadratic equation are real and equal, or real numbers, and they are equal. This is applicable if the discriminant is 0. Then lastly, third condition, imaginary and unequal, if the discriminant is less than 0, or if the discriminant is negative. Moreover, the roots are rational if D is a perfect square. So therefore, we can say that D is rational, and irrational if D is not a perfect square. Not a perfect square. So we can summarize that if the roots are positive, there are possible two natures. Okay, so the first one is real, unequal, and rational, or real, unequal, and irrational. lastly, next rather, real and equal if d is equal to 0. There's one nature for this one, real, equal, and rational. Then for the next one, if the discriminant is negative, you only have one nature or one category. For the nature, we have imaginary and unequal roots. Alright, so these are the four things that you have to remember. If the discriminant is positive, the solutions or the roots are real, unequal, and irrational, or real, unequal, and irrational. If the discriminant is 0, then the roots are real, equal, and rational. And if the discriminant is less than 0, we have imaginary and unequal roots or solution. So, solutions. Those are the things that you're going to remember. Next, let's have the first example. Determine the nature of roots of each equation. Letter A, x squared minus 6x plus 9 equals 0. You have to make sure that the given quadratic equation is arranged in standard form. If it's not, you have to arrange it. In this case, x squared minus 6x plus 9 equals 0 is already arranged in its standard form, therefore we can proceed. Then the next thing is, if you're able to arrange it in standard form, you need to identify the values of A, B, and C. Alright, so the value of A, which is the coefficient of x squared, is 1. And the value of B, which is the coefficient of x, is negative 6. And C is the constant, which is 9. Then, let us write the discriminant formula, which is D equals B squared minus 4AC. Substitute the values. B is negative 6. Do not forget to use grouping symbols. Minus 4 times A, which is 1, and C, which is 9. Actually, class, you can already simplify this one using your calculators. But if you are going to compute it manually, it goes like this. Negative 6 squared is negative 6 times negative 6, which is positive 36. Negative 4 times 1 times 9, okay? So the answer here is negative 36. Then let us subtract 36 minus 36. Therefore, the discriminant is 0. So the discriminant is 0. So let us now identify the nature of roots of this given equation, x squared minus 6x plus 9. We can say now that since D is 0, then the roots of x squared minus 6x plus 9 equals 0 are, okay, so the discriminant is 0. We can say now that the roots are real, equal, and rational. As simple as that. This is now your answer. So this is now the nature of the roots of the quadratic equation, x squared minus 6x plus 9 equals 0. As simple as that. Let's have letter B. X squared plus 6x plus 9 equals 0. So in this case, you have to check it first if it is arranged in standard form. So we can say that it is already arranged in standard form, beginning with the quadratic term, linear term, and the constant. So this is now arranged in standard form. Then you identify the values of A, B, and C. So the value of A, the coefficient of x squared, is 1. The value of B, the coefficient of x, is 6. And the constant is 5 equals, no. And then, after that, discriminant formula, D equals B squared minus 4AC. Substitute the values. So the value of B is 6 squared minus 4 times A, which is 1, times C, which is 5. Then you can directly compute this on your calculator, and then for the manual computation, 6 times 6 is 36, minus 4 times 1 times 5 is negative 20. Then 36 minus 20 is 16. The discriminant now is 16. So if the discriminant is 16, okay, so it falls under the first category, which is, okay, the discriminant is positive. Then take note that 16 is a perfect square, right? So 16 is a perfect square. Therefore, we can say that since the discriminant is 16, then the roots of x squared plus 6x plus 5 equals 0 are real, unequal, and rational. Rational because 16 is a perfect square. This is now the nature of the roots of the equation x squared plus 6x plus 5 equals 0. So what if, teacher, okay, b is missing, or the given quadratic equation is missing and bx is missing? So you can equate b to 0. What if, teacher, the constant is missing? You can equate c to 0 but not a. You cannot equate this to 0 because it will not become a quadratic equation. You have to go back to the condition of for an equation to become a quadratic equation. So the quadratic term must be present. So if a is equal to 0, the quadratic term will be removed. So you can equate b to 0 or c to 0. Let's have the next set of examples. Determine the nature of roots of each equation. Letter A, 2x squared minus 4x plus 5 equals 0. So check if it is arranged in standard form, and yes, it is already arranged in standard form. Then the next thing is, you have to identify A, B, and C. So A is 2, B is negative 4, and C is positive 5. Then compute for the discriminant using the formula b squared minus 4ac. Substitute the values. B is negative 4 squared minus 4, A is 2, then C is 5. So negative 4 times negative 4 is 16. Then negative 4 times 2 is negative 8. And then negative 8 times 5 is negative 40. So 16 minus 40 is negative 24. So the discriminant is negative 24. Now, it is negative. Therefore, we can say that since b is equal to negative 24, then the roots of 2x squared minus 4x plus 5 equals 0 are imaginary and unequal. So this is now the nature of the roots. Next, let's have the last example. 5x squared minus x minus 2 equals 0. Check if it is arranged in standard form. Okay, and yes, it is arranged already. Then you identify the values of a, which is 5, value of b, which is negative 1, and then the value of c, which is negative 2. Substitute to the discriminant formula, b squared minus 4ac. b is negative 1 squared minus 4 times a, which is 5, and c, which is negative 2. Simplify. Negative 1 times negative 1 is 1. Negative 4 times 5 is negative 20. Then negative 20 times negative 2 is positive 40. 1 plus 40 is 41. So D is positive and is not a perfect square. Therefore, we can say that since D is equal to 41, then the roots of 5x squared minus x minus 2 equals 0 are real, unequal, and irrational. So that's how you are going to get the nature of roots. So let's have a quick recap. To get the nature of roots or solutions, you have to use the discriminant formula, which is derived from the standard form, of the quadratic equation, which is ax squared plus bx plus c equals 0, we have d equals b squared minus 4ac. Then after computing for the discriminant, you have to identify. If it is positive, there are two possible answers. If it is perfect square, the nature of roots will be real, unequal, and rational. Then the next thing is, if the positive discriminant is not a perfect square, we can say that it is real, unequal, and irrational. Then if you got 0 as the discriminant, it is simply real, equal, and rational. Then lastly, if it is a negative discriminant, we can say that the nature of roots is are imaginary and unequal, as simple as that. Then when you are computing, you have to make sure first, okay, the given quadratic equation must be arranged in its standard form. If it is not, you have to do so, following ax squared plus bx plus c equals 0. Then after you have arranged it to standard form, you have to identify a, b, and c. Then that's the time that you can use the quadratic formula, or rather the discriminant formula, b squared minus 4ac, to compute for the discriminant and then identify the nature of roots. So if it is clear to you, let's proceed to the sum and product of roots. So for the sum and product of roots formulas, so these formulas were derived from the standard form as well. Okay, so ax squared plus bx plus c equals 0. So how are you going to easily solve for the sum and product without even solving for the solutions or roots? So the other way of solving is you have to solve for the solutions and roots, and then you have to add them to get the sum of the roots or solutions, and you have to multiply them to get the product of the roots. But in this case, these are the formulas that you can have, so that it is easy. It will become easy for you to solve for the sum and the product. For the sum, you just have to simply use negative b over a, and then for the product, we have c over a. Still, you have to make sure that it is arranged in standard form, ax squared plus bx plus c equals 0, before you can identify a, b, and c. Let's have the third example. Find the sum and the product of the roots of the following equations. A, x squared plus 2x plus 8 equals 0, and b, 2x squared minus 7x minus 4 equals 0. Let's start with a first. X squared plus 2x plus 8 equals 0. Is it arranged in its standard form? Yes. So if it is already arranged in its standard form, all you need to do is to identify a, which is 1, b, which is positive 2, and c, which is 8. Then we will solve first for the sum using the formula negative b over a. Then for the product, we have c over a. Let's start first with the sum. So substitute, b is 2, negative 2 over a, which is 1. Then negative 2 divided by 1 is negative 2. This is now the sum. Then for the product, substitute. Alright, so c is 8, and then a is 1. 8 divided by 1 is 8. So this is the sum, which is negative 2, and the product is 8, as simple as that. Then for letter B, we have 2x squared minus 7x minus 4 equals 0. Then the next thing is, if it is since it is already arranged in its standard form, all we need to do is to identify a, which is 2, b, which is negative 7, and c, which is negative 4. Then same thing, sum, the formula is negative b over a. Then for the product, the formula is c over a. So for the sum, substitute negative 7 over 2. Then here we have negative 4 over 2. Let's solve for the sum. Negative times negative 7 is positive 7 halves. And here negative 4 divided by 2 is negative 2. This is now the product, and here this is now the sum. Or you can convert this to the decimal. 7 divided by 2, 3.5. So those are the formulas that you can use to easily solve for the sum and the product of any quadratic equation. So I hope that you learn from our topic for today, roots of quadratic equation. So for the nature of roots, all you need to remember the certain conditions, okay, or certain steps, and then for the sum and product, just simply follow the formula. So I hope that you have learned a lot for this session. Okay, so for more videos about our mathematics lessons, okay, so you can subscribe on my channel, Reynaldo Palo, and then you can click as well the notification button so that you can be notified whenever there is a new video that is uploaded. Okay, so our YouTube channel is Reynaldo Palo, and again, this is Teacher Dong, and hope that you have learned a lot. Have a nice day ahead.